Let's take a look at another question. We have to find the total resistance and the current in the circuit below. So here's our circuit. All the information is here. We have to find the voltage and the current through each load. So we have to find, as you can see, we have 4 resistors. So we have to find I1, I2, I3, and I4. And we have to find V1, V2, V3, and V4. So these are our unknowns. Okay, and in order to determine the total resistance, first we have to simplify the diagram a little bit, and for this we have to examine it first. So as you can see, we have a resistor R1, and then we have these two that are in parallel. So we have a series within these two parallel, parts of the circuit, and we are going to bring these together first, and this is what it's going to look like. It's not going to be as pretty as the one that you see there, but I'll try. So here is the energy source. So delta V is 180 volts here, and we still have R1 right here. We're not doing anything with this. We still have the R2 here, so we're not doing anything with R2. And for R3 and R4, we're going to bring them together into one resistor, and we're going to call this by the name R34. Now, because these two are in series, then we add the resistance, so that would be equal to 24 plus 6, or 30 ohms. So R2 still 20, and R1 is still 24. Okay, so in order to find the total resistance, now we have to re-examine the diagram we have. So we have this one in series with these two. So now we have a parallel within a series. So in order to add these two resistors here, which is going to be 1 over R, because it involves resistors 2, 3, and 4, the total of 2, 3, 4 can be denoted by R234 is equal to 1 over R2 plus 1 over R34. So R2 is 20, so 1 over 20 plus 1 over 30. So we're going to add them together. So lowest common denominator seems to be equal to 60, multiply here by 3 and here by 2, and we got 5 over 60, which simplifies to 1 over 12. So 1 over R234 is 1 over 12, which will make R234 equal to 12. You can either cross multiply in here, or you see that if these are equal, numerators are equal, that means the denominators are equal as well. So that's 12 ohms. So now that we have brought them together, so we have brought together the R2, R3, and R4, we are going to re-simplify the diagram again. So again, let me give it a try. So we have the circuit. Here is the delta V equal to 180 volts. Let me make this red as it was before. And we have the resistor R1, and the resistor R234 now is altogether equal to we said 12 ohms, and this one still is 24. So as you can see now, R1 and R234 are in series, and the total resistance is going to be R1 plus R234, which is 24 plus 12, or 36 ohms. So with this, we have answered the first part of the question. So we're asked to find the total resistance, and the total resistance is equal to 36 ohms. Now, we're also asked to find the voltage and the current through each load. So I'm going to start off here. I want to find what the current is. So the current in this circuit, we can work backwards. I'm going to use green in here. So I total in this final circle is going to be V total divided by R total. And that would make 180 divided by 36. Now, 180 divided by 36, that would give about 5. And 5 amps is for the current, the total current. Now, because these two are in series, then we're going to say that I1 is 5 and I2, 3, 4 is also 5 because they're equal to each other, so in series. Let me just make a note in here. I'm going to put these numbers in here. So we have I1 so far equal to 5. And I know that 2, 3, 4 will make 5 as well. Now let's take another look at 2, 3, 4. Now you see that for 2, 3, 4, we have 2 in parallel with 3, 4. So we know that the voltage in here is 180, but the voltage drop will be different because this is in series. So we're going to revisit this, and we're going to say that here we got I1 equal to 5. And we know that I234 is also going to be 5 amps. Now, when we are in parallel, right, the voltage will be the same. When we are in series, the voltage will be the sum of the voltages. So we need to find what the voltage drop is in R1. So we're going to say that in R1, the voltage drop is going to be V1 equals I1 R1. So that will make it 24. That's resistance, 24 ohms times 5. And 24 times 5 will be equal to 120 volts. So 120 volts would be the voltage drop in I1, which means that the rest will be for the rest of the circuit. So we're going to say that we now have the voltage in 2, 3, 4 is equal to 180, take away 120, because 120 is the voltage in R1, and that will make 60 volts. Now, this will be the voltage in 2, 3, 4, right? Now, remember that because this is in parallel, then the voltage in each part of the circuit is going to be equal. So in other words, V2 will be equal to V34. It is equal to 60 volts. So we got V2, 60 volts. So, all right. And I'm going to write it down in here. V2 equals 60 volts. And now that we have V2 in here, we can easily find I2. Remember that current will be different when in parallel. So since we're at it, so we're going to say I2, let's find I2, is equal to V2 over R2. So that's 60 over 20. That's 3 amps. So we're going to say that I2 equals 3 amps. All right. Now, we said that the voltage in 3,4 will also be the same as V2, 60 volts. So what that means is that now that we have the voltage and the resistance, and we can say that the current, so the voltage in 3,4 is equal to 60 volts, and the resistance in 3,4 is, we said, 30 ohms. So that makes the current in 3,4 equal to, so 60 divided by 30, because that would be V over R. Let me just write the formula. So that would be equal to 2 amps. Now remember that 3 and 4 are in series. And in series, the current is the same. So we're going to say I34 is the same as I3 and same as I4, and that will be 2 amps. So we got I3, 2, and I4, 2 amps. All right. Now, the voltage drop in each resistor or in each bulb is going to be different because they are in series. So since we're at it now, what we're going to do is calculate the voltage drop here for V at 3 is going to be equal to, oops, sorry, oopsie, didn't mean to do this. So V at 3 is I3 R3. So that's 2 times 24. 2 times 24, we got a 48 volt here. And V4 is I4 R4. I4 is also 2, we said, right? And times R4, which is 6, that's 12 volt. And as you can see in here, the voltage here is 60, and in series, they are in series, and it does equal 60 right here, so 42 plus 12. So we have V3 now, which is 48, and we have V4 that is 12 volts. And with this, we've answered almost every question. Let me see here. So we found the total resistance, so we answered that question. We found the current in every resistor, and we found the voltage drop in every resistor. And I hope you found the instructions useful. One thing that I would actually emphasize in here is to write down the numbers or what the unknowns, and then fill them in as you find them, because there's so many unknowns all over the place. And when you organize them, it's easier for you to see what you've already found, and you don't have to go back and forth in circles, because that can happen sometimes, especially when we write tests. All right, bye for now, and thanks for learning with me.